Okay, let us mark these activities. Remember, what we're looking for are simply common brackets. And just because they look the same, it doesn't mean that brackets are exactly the same. They have to be exactly the same. A negative term in one bracket must be a negative term in the other bracket. Otherwise, we can't take the whole bracket out as a common factor. Now, let us look at this first one here. You'll realize that these two brackets are pretty much similar. However, the second bracket is 2 minus x instead of it being x minus 2. So we need to do something with the second bracket by taking out a negative common factor. Okay, now when I take out negative as a common factor, in this case, if I take out negative as a common factor, I will end up having, I will have 2 times x minus 2, but this x here is going to be negative x, and in brackets I will have x minus 2. Now this becomes a common factor. I will simply, which is a common bracket, I will simply take it out as a common factor, and I'll be left with 2 minus x, and that's it. Okay, that's how you will solve for that one. Here you have a choice of changing the first bracket by writing it as y minus 3 and take out negative as a common factor. But I will not do that. I will instead change the second factor by writing it as 3 minus y. And then you realize that this y that is outside here has changed signs. It's now negative. That is because we have swapped the terms inside that bracket. And now this is our common bracket. We're going to take it out. Note that if I take this whole thing out as a common factor, I will be left with 1 over there. So I'll be left with 1 minus y. Here I will write this as y minus 4 in the second term. I will write that as y minus 4. Outside the bracket, I'll have plus y. When I take out negative as a common factor, the sign will change and become positive. And this is a common bracket, so y minus 4 is a common bracket. When you take it out, I'll be left with 4 plus 1. Which can be written as y plus 4. Note that here, it's a tricky one. I've got t as well as t to the exponent of 3. When it comes to variables, a variable with the lowest exponent will be the common factor. When it comes to integers, 3 and 6 have one common factor, and that common factor will be 3. So here, if I take out 3, I'll be left with 2. I'll be left with 2t because I will have taken t squared as a common factor. However, when it comes to brackets, I can't change this. Well, I can't take this as a common factor. I have to take the second bracket, write it as a minus b. And for me to do that, I'll have to take negative as a common factor, resulting in this sign changing to become positive. Now I can take out my common factors. As I've said, it will be 3t squared. So if I take out 3t squared as a common factor, and I take out this a minus b, in the first term, what am I left with? I took this whole thing out as a common factor. Since I took the whole thing out as a common factor, I'll be left with 1 in the first term. I'll still have plus, and if I take out this, and from 6, if I take out 3, I'll be left with 2. From t cubed, if I take out t squared, I'll be left with t. And obviously this whole bracket is gone, so that will be my factor. What is a common factor here? Before I even look for the common factor, look what I have here. So I will simply change this one here and change this one and make it negative. So it will be 1 minus r, and negative r is a common factor. But now when I take out a common factor, I've got a common bracket, and I also have 7 as a common factor. So if I take out 7 there as a common factor, I'll be left with 2. If I take out r as a common factor here, I'll be left with r. Okay, meaning that if I take out 7r, 1 minus r as a common factor, in brackets, I'll be left with 1 minus 2r. All right. For this one, I'll just give you the answer as it is. And on this one as well, I'll give you the full answer. Try it out on your own and check out the answer when you're done. Today we'll be doing a difference of two squares, and I will start by explaining what a difference of two squares is first, okay? We will be factorizing the difference of two squares. Note that factorization is all about finding factors that when simplified will result in a given product. So I'm giving you a product and I'm asking you to work backwards to find the factors of that product. Here you will need to find factors that will lead to a product that is the difference of two squares. Okay, let's take for instance, I'm asking you to factorize this here. Why do we call it the difference of two squares? It's because the first term is a perfect square, which is x squared. This is a perfect square. The second term, which is y squared, is also a perfect square. And this here is minus, and minus is called what? A difference. That's why, because we've got a perfect square subtracted from another perfect square, that's why we say it is difference of two squared, because they've been subtracted from one another. Now, to get the above product, you will need to multiply a binomial with a binomial. To find the factors of the first term in the above product, which must be the first terms in each bracket, you need to find the square root of the first term of the product. So you will need to find the square root of x squared, and then find the square root of y squared. And those will be the last and the first terms in each bracket. The square root of x squared, you have done this earlier on. Under exponents, the square root of x squared will be x, and the square root of y squared will be y. These will be the factors that we have in each bracket. In the first term, as the first term in each bracket will have x, and as the last term in each bracket will have y. So you're going to have two brackets, but because we are dealing with the difference of two squares, brackets will have different signs. So you're going to take the first bracket. In the first bracket, it doesn't matter whether you start with plus or minus. I will start with x minus y, close the bracket, open the bracket, x plus y, and close the bracket, and those will be my factors. This is what factorization is all about. It's just about finding factors. Remember how I found these two? I took the first term, which was x squared. I found its square root and it gave me the x. For me to find these two, I took the last term, which was y squared. I found its square root and it gave me 1. then obviously brackets will just have different signs. And I need to emphasize, just because I started with minus, you can start with plus by writing it as x plus y and x minus y. It's totally up to you, okay? Let us look at this. You will need to find the factors of x squared. What are the factors of x squared? I mean, the square root of x squared. We know that we're going to have two brackets. Find the square root of x squared. What is the square root of x squared? It is x. Those will become the first terms in each bracket. And your last term is 4, so you will just find the square root of 4, and the square root of 4 will give you 2, and those will be the last terms in each bracket. And then obviously, if I start with plus, the next bracket must be minus. That's how you factorize using the difference of two squares. Note that when you find the square root of a variable or a number, you're simply dividing its exponent by 2. We've spoken about this under exponents. Similarly, if I have the square root of 4, it'll just give me 2. For that one, it's just a perfect square. You will know that it'll just give you 2. And as I've said, in the first term, we're going to have x minus 2. In the second term, we're going to have x plus 2. Or someone could have started with x plus 2, and in the second term, you have x minus 2. That's still correct, okay? Here, both brackets will have the first term of x and the last term of 2, but they will have different signs. Now, let's check if we can get the product given by multiplying out the above binomials. Obviously, guys, if you have a difference of two squares, to get the given product, you will just multiply the first with the first and the last with the last, and you'll end up having x squared minus 4, which is just the shorter method. Or you can go the longer way, the longer route, by using 4. Note that here we have x minus 2 and x minus 2, that will give you 0. Just need you to remember this quickly, that factorization is about finding factors, and you are given the product to find to find out if the factors are the right factors. You simply multiply them out, and you should get back to the given product you have been asked to factorize. Let's factorize this quickly. What are the factors? You find the square root of y squared, which is y and y, and the square root of 9 will be 3 and 3, and brackets will have different signs. Here you'll find the square root of 4. What is the square root of 4? It's 2 and 2. So in each bracket, the first term will be 2 and 2, and the square root of x will be how much? So all I did here was just to find the square root of 4x squared. So the square root of this integer here is 2, and the square root of x squared will simply be x. This will be the first terms in each bracket, and I'll find the square root of 81, and the square root of 81 will just be 9. This will be the last term in each bracket. Brackets will just have different signs. What about this? So 25a squared minus 16 will be 5a minus 4, and 5a plus 4 multiplied. So a difference of two squares will always result in a binomial being multiplied with a binomial. Now let's factorize this. Here you needed to be careful. You needed to check whether you have a common factor. Remember, that is the mother of all factorization. First step, check if there's a common factor. And you realize that we do have a common factor here, and the common factor is 4. So I'm going to take out 4 as a common factor. In brackets, I'll be left with a squared times b squared, and I'll have minus 9. Now, this is a difference of two squares, and you'll just have to factorize it by finding the square root of each term and allocating different signs to each bracket. Note that the common factor is the lead of all factorization. I always say it is the mother of all factorization. Therefore, take out a common factor first before using any other factorization method, which is what I did. And when I factorize this, this is the answer that I got. Good? Okay. Factorize this one. Do we have a common factor? That's the first thing that you need to check, and the answer is no. So you just have to square root 49. So let's square root 49x squared y squared. How much are we going to get here? Remember, when you have a square root like this, you can allocate the square root to 49, allocate the square root to x squared, and allocate the square root to y squared. You can only allocate the square root when you're dealing with division and multiplication. Since they're multiplied, you can allocate the square root to each factor. And obviously, the square root of 49 is simply 7. The square root of x squared is just x, and the square root of y will just be y. That's how we got to this answer, okay? And when you find the square root of 64, the square root of 64 will just give you 8. So in each bracket, the last term will be 8. In each bracket, the first term will be 7xy. Let's check this one out. Guys, note that when you factorize, you factorize up until you can't factorize anymore. Okay, it's like working hard. You work hard up until you can't fail anymore. So you study hard up until it becomes impossible for you to fail. And that's what maths is all about. When you practice smart, you end up reaching a point where you cannot, it becomes impossible for you to fail maths because you have so much knowledge to solve problems that you face, and that also helps you with real life problems that you just need by all means to work hard when it comes to your studies. That will solve a lot of problems when you are grown up. Now, in this case, please note that I'll simply find the difference of two squares. I will start by finding the square root of r to the exponent of 6. The square root of r to the exponent of 6 will be r to the exponent of 3. How did I get that r to the exponent of 6? When you're dealing with the variable and the exponent, note that the square root carries 2 there. All you have to do is just to take that exponent, which is 6, and divide it by 2. That's how I got to the 3. And that's why we have r to the exponent of 3. And your factors here, when I find the square root of 1, the square root of 1 will just be 1. So in this case, I'll have as the first term in each bracket r to the exponent of 6. In the second bracket, I'll have r to the exponent of 3 minus 1. Okay, check out this classwork. Try it out. Let me try and give you 5 minutes quickly. Please take 5 minutes again to try these ones out. Okay, I will start by doing solutions. You just pause for 5 minutes and try this one out and then check the solutions. And you just press play and continue to check the solutions. Don't cheat, because when you cheat, you're cheating yourself. Okay. Now we have 4d to the exponent of 8 minus 81. So you will simply find the square root of 4d to the exponent of 8. Okay, let's just do that quickly. So square root of 4d to the exponent of 8. This will be 2d to the exponent of 4. Okay, but please note that I can still factorize that. Okay, but for now, obviously, you guys wouldn't be able to do it right now, so I'll just leave it like that. And the reason why you guys won't be able to do it is because there's 2 there. Okay, but you can simply write this as square root of 2d to the exponent of 2 minus 3, and in the other side you have square root of 2d to the exponent of 2 minus 9, and that can still be factorized further, but yeah, that is a little bit on a higher level. For this grade, you just leave it like that, because that 2 is not a perfect square. There's no way that you can factorize that first bracket. Okay, what about the second term? Before you try anything there, the second question, before you try anything there, you needed to take out a common factor, which was going to be -2. And note that by taking out -2, this b squared is now positive, and negative, the positive has turned to negative. That is because you took out negative as a common factor, as much as you took 2 out as a common factor. What you left with inside the bracket is also a difference of 2 squares, and when you find the square root of b squared, you'll get b. The square root of 9 will be 3 and 3. For this one here, when you find the square root of that y to the exponent of 6, it will be y to the exponent of 3. And when you find the square root of 36, it will give you 6. So you have y to the exponent of 3 minus 6 and y to the exponent of 3 plus 6. Or you can write it in reverse by writing it as y cubed plus 6 and then y cubed minus 6. It's totally up to you. Now, when you find the difference of 2 squares here, you will end up with x squared y squared t squared minus 1 over 2, and x squared y squared t squared plus 1 over 2. This is a tricky one. Okay, firstly, I'm going to start by finding the square root of m to the exponent of 16. What is it going to be? What is it? It will be m to the exponent of 8. And what is the square root of 1? The square root of 1 is just 1. So you get another perfect square that you can still find a perfect square of. So I'll end up having m to the exponent of 8 minus 1 and m to the exponent of 8 plus 1. But please note that I can still factorize this one here by finding the square root of m to the exponent of 8. What is m to the exponent of 8? Is m to the exponent of 4. And what is the square root of 1? It is still 1. So that I can simply factorize it as m to the exponent of 4 plus 1 and m to the exponent of 4 minus 1. And again, I can still factorize that. What is the square root of m to the exponent of 4? It'll just be m squared. So I'll have m squared in each bracket. And then I can factorize m squared again. When I factorize m squared, it will simply give me that, okay? And when you reach that point, you cannot do anything. Someone might be asking, but then why haven't we been factorizing the other ones? Why are we not factorizing this m to the exponent of 8 plus 1? That is because that is a sum of 2 squares. We cannot factorize the sum of 2 squares. Again, here, all of these are sums of 2 squares. We cannot factorize a sum of 2 squares. Remember, plus simply means a sum. So a sum of 2 squares cannot be factorized. Write that and make sure you don't forget it. The sum of 2 squares cannot be factorized. That's why I kept on writing all of those, because I couldn't factorize them. Okay. When you look at this, you'll realize that I have a common variable, which is m. I will just take that out as a common factor, and then I'm left with a difference of two squares, which will be 2m minus 3 and 2m plus 3. For this one here, it's tricky. So it's pretty much the same as that m to the exponent of 8 will have b to the exponent of 4 plus 9. That is the sum of two squares, so I cannot factorize this. However, I can factorize that because it is a difference of two squares. When I factorize it, it will give me that. I can't factorize these, but I can still factorize that, okay, which is beyond your syllabus. But for now, you will just leave it there because this 3 here, when you find its square root of 3, it'll give you an irrational number. So you will just leave it as 3. That's why I can't factorize beyond this step at this level, at grade 9 level, okay? Here we also have a common variable, which is mn. I will simply take that out and I'm left with the difference of two squares and I just factorize that. Here it's pretty tricky because I have a common vector of 4 and I also have a common bracket of m minus 1. And I'll just take those ones out as a common factor. But please note, after doing that, I'm left with this, which is just the difference of two squares. When you factorize it, it'll give you v plus 2 and v minus 2. Okay? All right. Aha, how do we factorize that? I know someone is tempted to say it's 2b plus 5 and 2b minus 5. Incorrect. Here, guys, we cannot factorize this because it is a sum of two squares. As I've said, sum of two squares may not be factorized, so I'll just leave it like that, okay? What is the answer here? It's 4x squared plus y to exponent of 4 and 4x squared minus y to exponent of 4. Can I still factorize this? Firstly, can I factorize that? Why can't I factorize this? It is the sum of two squares. I can't. But this one I can factorize. Give me the factors then. It is 3x plus y and 2x minus y. For number 10, what must I do first? Take out 2 as a common factor, and what am I left with? You'll be left with the difference of two squares, which we can still factorize, and that will be 4a squared minus 25, and that will give us 2a plus 5 and 2a minus 5. All right, let us check the next ones. Seems like my number is incorrect here. The next one, obviously, the first bracket will be on its own a perfect square. So when you find the square root of that 3y minus 2 squared, it'll just give you 3y minus 2, which will be your factors in each bracket. And if I find the square root of 4, it'll just be 2 and 2. So it's like this. I've got the square root of 3y minus 2 squared. Note that this will simply be 3y minus 2. You just take this exponent, you divide it by 2, which gives you 1, and this will give you 3y minus 2, which becomes the first factor in each bracket. So you'll have 3y minus 2 as well as 3y minus 2. And when you find the square root of 4, the square root of 4 will just be 2, which will be 2 and 2, and brackets will have different signs. Okay, now in the next step, I'm simply going to simplify what is inside these big brackets, okay? I'm going to simplify what is inside these big brackets by just getting rid of those smaller brackets, okay? Please note that for this term here, this bracket and that bracket, because there is no a variable multiplied by them, I can just drop those brackets and just change the bigger brackets to smaller brackets. Now I'll end up having these two, okay, added up. Minus 2 plus 2 will give me 0. Minus 2 minus 2 will give me minus 4. And ultimately, when I fully factorize, this is what I'll be left with. Similarly here, I've got 2 as a common factor. So if I take out 2 there as a common factor, I'll be left with 4 because the factors of 8 will be 2 and 4. So I'll take those out as a common factor, okay? But I can't take out a common bracket. So what I'm going to do now is just to take out the 2. Once I've taken the 2, if you are not aware, you might be fooled by thinking that this is not a difference of 2 squares. It is a difference of 2 squares. It's just that this whole thing is squared, and that whole thing is also squared. And the factors of 4 will be 2 and 2. But the factors of this whole bracket here will just be x plus y, and the factors of this whole bracket here will be x minus 2. And obviously, you just put plus and minus in between, which is a difference of 2 squares. Okay, I hope you guys enjoyed that. If you need more practice, I've had students asking me for more practice. Can try this, which is a bit higher level. And then you can try that, which is higher level, which is important for higher grades. Okay, if you need more exercises, like you guys have been asking for more exercises, these are the exercises. I gave them to my support class, try them out. Now, time yourself, give yourself 10 minutes to do all of these. And then afterwards, press play to check out the answers. Give yourself another 10 minutes to try these ones as well. And press play to check the answers. Remember, taking out a common factor is the mother of all factorization, okay? And when you take out a common factor, sometimes it will be a common bracket, sometimes it will be a variable, sometimes it will just be an integer. And you need to remember the rules for taking out a common factor. If it's an integer, the rules for taking out a common factor when it's a variable, and the rules for taking out a common factor when it's a bracket. Taking out a common bracket and a common variable is pretty much similar because you look for the same variable and you take out the variable with the lowest exponents in each of those terms. Okay. These are more questions you can try out. Okay, guys, next time we're going to be doing factorization of trinomials, and I realized that I didn't do all the corrections on that. If you have questions, you will let me know under the comments, or just send me the email if you need answers to some of the questions, okay? I hope you enjoyed the lesson on difference of t-squares. On that next lesson, will be factorization of trinomials. You need to ask yourself important question. What is a trinomial? Trinomial is simply an expression with three terms. Try three, okay? Where the highest degree is 2. If the highest degree is greater than 2, then you need to take out the common variable as a common factor, okay? For now, factorizing the degree of 3 and stuff will simply be done in hybrids. Otherwise, you just need to look for where the first term, even if it's an odd, you first check if there's a common factor, but it's an even number, check the middle term. And let's say, for instance, the first term has x to the exponent of 6. Make sure that the middle term has x to the exponent of 3, then that can be factorized, okay? And we'll simply be taking it from the top and doing more of these and combining this with taking out a common factor, difference of two squares, and everything else. Check out the next video, okay? Hope you enjoyed this lesson.